Next, let's prove that the sine of pi over 2 minus theta is equal to the cosine of theta. We'll start with the more complicated side, which is sine of pi over 2 minus theta, and then we'll use the difference formula for sine. So that's going to be sine of pi over 2 cosine of theta minus cosine of pi over 2 times the sine of theta. Now we can evaluate the trig functions that have the pi over 2 in them. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. And that simplifies to just cosine of theta. Notice that in a proof, you really need to put all the steps in. Don't skip any of these. Here's another formula for us to derive. Let's derive a formula for tangent of a plus b. So tangent of a plus b. So in other words, we're going to derive a sum formula for tangent. How would we do that? Well, we know that tangent is sine over cosine. So I've got sine of a plus b over cosine of a plus b. And now I can use the sum formulas for both sine and cosine. So for sine, I'm going to have sine of a cosine of b plus cosine of a sine of b. And for cosine of a plus b, I'm going to have cosine of a cosine of b minus sine of a sine of b. Now that is a perfectly good formula, but we would really like to have our formula for the tangent of a plus b to have tangents in it, not all these sines and cosines. So here's what we're going to do. I'd like all the sines in this thing that we just derived to have a cosine underneath them, because sines over cosines can be turned into tangents. So let's multiply by 1 over cosine A cosine B. And of course we have to multiply by the exact same thing in the denominator, so that we're just multiplying by a giant 1. Now we'll distribute this in to both terms in both the numerator and the denominator. So at that point, I will have sine of A cosine of B over cosine of A cosine of B plus cosine of A sine of B. And after we simplify this, you'll see why I picked the thing I picked, this thing. You'll see how it all simplifies down nicely. Anyway, so let's see, I have cosine A sine B over cosine A cosine B, and down below I have cosine A cosine B over cosine A cosine B minus sine of A sine of B over cosine A cosine B. Now, stuff's going to start canceling here, right? So like on top, those two cosines of B's cancel. In the upper right, the cosine of A's cancel. The lower left, everything cancels. And that's all the cancellation. So let's write down a clean version of what we've got. We've got sine of A over cosine of A in the upper left. then minus, plus. In the upper right, we have sine of b over cosine of b. Lower left, we have a 1 because everything canceled. And I'm going to rewrite that thing in the lower right as sine of a over cosine of a times sine of b over cosine of b. Hopefully you agree that that's the same as the line above. Now all of those things turn into tangents. So I have tangent of a in the upper left, tangent of b in the upper right, and then I have 1 minus tangent of a times tangent of b down below. So we have now derived the sum formula for tangent. I'm going to not derive the difference formula. I'm just going to give them both to you here. So, and unfortunately, this is yet another one that needs to be memorized. Because as you see, you can derive it, but it is a bit time consuming. Okay, so for tangent of a plus b, we came up with tangent of a plus tangent of b over 1 minus tangent of a tangent of b. And the only difference with the difference formula, so if I'm doing a minus b, I'm going to have a minus on top and a plus down below. So tangent of a plus or minus b is equal to tangent of a plus or minus tangent of b all over 1 minus plus tangent of a times tangent of b.